Hi, this question is asked in UGC NET exam October 2020. The question is machine with byte addressable main memory of 2 power 16 bytes. This is byte addressable and the block size is given 8 byte and the cache is used, direct mapped cache is used, and the number of lines is given 32 line, and we have to find number of bits in tag, line and word field. So we know that suppose this is main memory, okay, and main memory has 32 line, 32 block, 0 1 2 31, and we have cache memory also, and the cache memory has 4 line, 0 1 2 3. This is line number. We know that cache memory contains frequently accessed pages from main memory. So if you program access pages from main memory, it will take longer time, as main memory access time is longer than cache memory access time. So frequent page will be contained in cache memory to execute our program faster, but we can't contain a whole of the main memory in cache memory. So here is some technique applied. One of the technique is direct mapped cache. In direct mapped cache, what will we do? This is the format of address. 3 part is there. First part is tag bit, second part is line number, and third part is offset. This may be byte offset or word offset. As this is the this is byte addressable memory, so here we will consider about byte offset. So here block size given 8 byte. Suppose we have to access 15th block and 6th byte. Okay, so this 6th byte is the byte offset and the 15 is the block number. But we see that in cache only 4 line can be contained, can be stored, and so for distinguish the block number, we use tag bit. So how we find line number? For line number, we can use number of block number modulus operator number of line. Okay, so here 15 modulus number of line is 4, it will be 3. So the 15th block will be stored in third line. So third line, and line size is always equal to block size. So the block offset will be line offset. Okay, so 6th byte in block, that means 6th byte in line. So this is the format of storing address. So we see that for line number, how many bit will need. So we see that for that we divide blocks, number of block by number of line. Okay, here 32 divided by 4 equal to 8. That means one line will map to 8 block. Okay, so this 8 block, for 8 block we need how many bit? We need 3 bit to represent. Okay, so this is the tag bit. So here 3 will be there, and line number how many line is there? Line is 4 line, and for that we need 2 bit, so 2 bit will be used. And byte offset block size is 8 byte. For that we need 3 bit, as 2 power 3 equal to 8, so 3 bit will be needed, so here 3 bit will be byte offset. Okay, so using this method we can solve the question. Here main memory size is given, main memory size equal to 2 power 16, block size is given 8 byte equal to 2 power 3. So number of block will be main memory divided by block size, 2 power 16 divided by 2 power 3, 2 power 13. So this is the number of block. Okay, and the number of line for cache memory, number of line is given equal to 32. This is 2 power 5. And the line size equal to block size, we know the both are equal. This will be 8 byte, that means 2 power 3 byte. Okay, so we see here one line represent 2 power 5 line will represent 2 power 13 block. Okay, so one line represent how many block? 2 power 13 divided by 2 power 5, it will be 2 power 8 block. Okay, so this is the format. Okay, tag bit, line number and offset. First we determine this. Offset is the offset of byte in particular block. So for this we need block size, and block size is 8 byte. Okay, and for this we need 3 bit, as 2 power 3 equal to 8 byte. So why do we need 3 bit? Because with 3 bit we can represent 8 byte, 0 0 0 0 0 1 0 1 0 and so on, 1 1 1. This is 0th byte, this is first byte, this is second byte, and so on, this is 7th byte. Okay, so for this we need only 3 bit to represent offset. Now line number, how many line number in cache? So we see that there is 2 power 5 line. So for this we need how many bit? 5 bit will be needed. So here 5 will be number of bits in line number. And how many bits in tag? So we see that one line is representing 2 power 8 block. Okay, so this is the content, but which block is it representing? For this we have to, because one line can represent 2 power 8 block. For this, at one time only one block can be stored in line, in cache line. So which block is stored? For this we use tag bit. So one line represent 2 power 8 block. For this we need 8 bit. So here 8 will be number of bits in tag, so that for 8 bit we can represent 2 power 8 block.